All right, hello, Algebra 2 people. So we're going to spend today talking about and kind of introducing transformations. I think you might have seen a little bit of transformations last year in Algebra 1, but probably not as into it as kind of as we're going to be getting this year. And certainly there's some other notations and stuff like that. So remember yesterday we talked about function notation, and this is really going to be the big part of why we did that yesterday. So all of this is going to be in terms of some function f. Now I want to point out at the very top of the screen here, there's two different things. So the top one says f of x equals a times f parentheses b parentheses x minus h and then plus k. And the bottom one basically the same, but instead of h and k, it says c and d. I did that mainly because depending on the textbook you have or the teacher you have or whatever, h and k can sometimes be written as c and d. They're kind of interchangeable. But the important thing is they mean the same thing and they do the same thing. Okay? So let's talk about what each of these letters do. And remember, f is just the function. It can be any one of the parent functions, which we'll talk about that in a few minutes. But a, b, c, and d, or h and k, we need to see what they do. And I'm going to give you a little demonstration at the end of this, talking about a kind of visual representation of what each of these things do. Okay? So let's start off with a. Notice a is a multiplying factor of the whole function. Okay? So what that means is it's going to be a vertical stretch or a vertical compression. If a is greater than 1, and 2, 3, whatever, anything bigger than 1, it is a vertical stretch, which visually, that usually means it's going to get either thinner, steeper, something like that. And those different words you can use for that. But it's a vertical stretch. If a is less than 1, then it is going to be a vertical compression or vertically compressed. Which that means just the opposite, right? So it's going to get wider, it's going to get less steep. And again, we'll see the visual on that in just a minute. And then the other thing that a can do, and notice that is just the actual value of a, what we call the absolute value of a. So it doesn't really matter if it's positive or negative for that to happen. Anytime the value of a is greater than 1, it's a vertical stretch. If it's less than 1, then it's going to be a vertical compression. But what can happen if the sign of a is negative, it is automatically, doesn't matter if it's, what the actual value is. If a is negative, it's a reflection across the x-axis. In other words, it's upside down. Okay? And that is any time a is negative, less than 0. Okay? So that's what a does. Let's look at b. So notice b is also a multiplying factor, but this time it's inside the parentheses, basically attached to the x. Okay? So this is going to be a horizontal change of the graph. But the thing to remember here, and I'll have more to say about this in just a minute, the thing to remember here is it's kind of backwards from what a does. And what I mean by that, now if b is greater than 1, this is going to be a horizontal compression or horizontally compressed. And if b is less than 1, again, fraction like 1/2, 2/3, whatever, that is going to be a horizontal stretch. Okay? So it's kind of backward from what a does in a way, but that is, and again, I'll show you the visual of that in just a minute. The other thing that happens is if b is negative, again, just like a was, if b is negative, now it's going to be a reflection across the y-axis, which basically means it's going to be going backwards. Now, I will say on most of the parent functions, we just don't worry too much about the b value. for a variety of reasons. I will show you a couple different functions that kind of make more sense with the b-value, and there's one function that we won't see at all in Algebra 2, but it's the best one to really see what it means to be horizontally compressed or horizontally stretched. I'll show you that in just a minute. The last two letters, these are the easy ones, really. And it's H and K, or again, C and D, depending on the book or something like that you're looking at. So notice, again, for the H, notice it's inside the parentheses. And also notice that the formula itself says X minus that value. So look here, if you see f of X minus H, that means H is greater than 0, right? So in other words, H is positive, and that means it's going to go to the right. If you see f of X plus H, that really means it's f of X minus a minus H. So that means H is less than 0. Anything H is negative, and that's going to mean it's going to the left. Okay, and it's a straight up shift, like literally moving everything, all the whole graph, so many units left or so many units right. Same thing with the K or D value. Notice that is being added or subtracted on the whole outside of the function. Okay, this one is just the way it looks. So if you see a plus something on the outside, that's being shifted up. If you see a minus something on the outside, that's shifting the whole thing down. Okay? Now, the last thing I'm going to say before I show you some of these kind of examples of this is I want to bring your attention and kind of show you the relationship between A and K. Notice A is on the outside of the function, K is on the outside of the function, and they both change the graph vertically. A is your vertical stretch or compress, and K is your vertical translating or shifting up and down. Whereas the two things that are inside, B and H, those inside guys change the graph horizontally. So B is your horizontal compressor stretch, and H is your shifting right and left. Okay? Now, the last thing before I leave the screen, and if you need to pause the video so you can make sure and write that down and have a good idea of what that is this is your list of parent functions. We're not going to be concerned about specifics on the parent function in this unit. As we go through the year, we'll be talking about each of these things individually and talking about specifically what each of those graphs look like with the different transformations. Okay? Mostly, we are going to be concerned with A, H, and K. A little bit of B, but mostly B isn't going to come until you get to pre-calculus and talking about trigonometry and the sine functions. Okay, so I'm going to bring this back up to the top here real fast. And if you need to pause the video real fast, I'm going to go around to the other side of my computer and I'm going to show you this demonstration that we have. Okay, so if we click on this, so this is something I made a year or two ago in Desmos, and I will put the link to this in the description of the video down below. But here's, so when you click on the link, you can play around with all these different functions and do the different transformations. I'm just going to do the quadratic function. I think that's something that everybody's familiar with at the beginning of Algebra 2. And kind of show you these, and I'll show you one or two others with some of the transformations, but we're going to kind of start off with that. Okay, so notice here's my parabola again, standard parent function. Okay, and notice my A is on the outside, the B and the H are inside, the B and the H are still being squared by everything, and the K is on the outside. So let's move A around and see what happens. So if A is positive, notice if it's greater than 1, I should say, now it's getting bigger, it's getting steeper, it's getting thinner, however you kind of want to describe that. But now look what happens if I start bringing A less than 1. but still greater than 0, now it's getting wider. Okay, and also note now if A is negative, if I go all the way to -1, notice it has just flipped that whole thing upside down. It's reflected across the x-axis. If A is between 0 and -1, again, it's still getting wider. If A is bigger than 1 but negative, it's going steeper. It's just upside down from what it was at the beginning. How about the h and k values? I'm going to do b in a minute with a different function, but how about for h and k? Again, h, if h is positive, it's going to the right. But again, remember, if h is positive, you would see x minus that number, because again, that's just part of what the formula is. So if h is positive, shifting the whole thing right. If h is negative, shifting the whole thing left. And then finally for k, if k is positive, remember that k is on the outside of the whole function. If k is positive, shifting the whole thing up. K is negative, shifting the whole thing down. Okay, the shape is not changing. It's not being vertically stretched or anything else like that. It's just moving the whole thing up and down. Okay, now let me show you one where the b value can kind of make a difference. And again, it is a function that you have not seen before, at least not in a whole lot of detail. It's called the sine function. Okay, so don't wig out and don't worry about it if you've never seen this function before. But this is a good representation of the difference between A and B. Okay, so for A, we already said it's a vertical stretch. So I'm going to do that with this function too. Notice if A is greater than 1, it's just getting taller, basically. It's not doing anything other than, notice the x-intercepts are all staying the same. It's just getting steeper or taller. That's a vertical stretch. If A is less than 1, it's getting flatter or less steep. Okay, but now let's compare that with what happens if B is greater than 1. Remember on the notes, we said that if B is greater than 1, it's a horizontal compression. Well, what would that mean? If you're horizontally compressing it, it's going to bring all those points closer together. If you've ever seen a slinky, if you've ever played around with like a slinky, I think a slinky is a good representation of a vertical compression as it gets closer together. But then again, notice if B is less than 1, if it's a fraction, it's a horizontal stretch. So now it's going to get all spread out. Notice the height did not change on either of these. So the height was always the same from -1 to 1. It's just a matter of it's a stretch or a compression. Okay. Also notice, and I'm going to show you one more function with regards to B. I'm going to do one like the square root function. And we talked about those parent function. Remember, the square root function just goes from 0 to infinity. Well, watch what happens if B is negative. In other words, if it's a reflection across the y-axis, we know that's going to be backwards. So there's your negative B value. And it's just reflecting across that y-axis, going backwards instead of the normal direction. Okay. So that is your kind of overview of all things transformations. I'll do a separate video going through some examples of kind of the problems you're going to see and different kinds of like word problems and just identifying different transformations. I'll do a separate video on that and we'll post that on a different day. Until next time, stay safe.